Hi, welcome to the Olympiad geometry. Let's continue our study on the 9-point circle. Here is a problem. Let IA, IB, IC be the centers of side tangent circles of triangle ABC. Show that 9-point circle of triangle IA, IB, IC is the circumcircle of triangle ABC. The second one, perpendicular lines from IA to BC, IB to AC, IC to AB are concurrent. Okay, the first thing is that we have a triangle ABC and we find the centers of the side tangent of triangle ABC, right? For this one, I like to do this plot. Right, so here we have A, B, C. How can we find the center of the side tangent circle? We actually find the angle bisector lines here, right? Angle bisector of this angle and angle bisector of this angle. So we know this is IA, right? And angle bisector of this angle, roughly say like this, right? So this would be IB, this would be IC, right? So the thing we want to prove is that the 9-point circle of triangle IA, IB, IC is a circumcircle of triangle ABC, right? Think about this. Circumcircle of triangle ABC, that means ABC are on its circumcircle, right? That's fairly easy to understand. And we want to prove that circle is the same to the 9-point circle of the triangle IA, IB, IC. Basically, it's saying that ABC are on the 9-point circle of triangle IA, IB, IC, right? So we can directly connect AIA here. And we just let's just do a little research on the AIA, right? Think about this. This angle equals to this angle, right? And because the distance from IA to AB equals to the distance from IA to AC, that means AIA is also the angle bisector of angle BAC, right? So this angle equals to this angle, and also this angle equals to this angle. Notice that these four angles, they all are equal, right? And this one equals to this one. So let's set this as alpha, this as beta, right? So we have 4 alpha, 1, 2, 3, 4, plus 1, 2, 3, 4, 4 beta equals to 360 degree, right? Which means alpha plus beta equals to 90 degree, right? That means AIA is perpendicular with AIB, right? AIA is perpendicular with AIB. Similarly, BIB is perpendicular with BIC or BIA, whatever. That's the same thing. And CIC is perpendicular with CIA, right? which means IA, AIA, BIB, CIC are the altitudes for the side ICIB, right? This for the side ICIB, this for the side IAIC, this for the side IAIB, right? They are altitudes of this side. Of course, that A, B, C are on the 9-point circle of the triangle IAIBIC, right? That's the foot of the altitude. So we just prove this one. And the second one, perpendicular lines from IA to BC. IA to BC. So this is perpendicular. IB to AC. So this is perpendicular. And IC to AB. This is perpendicular. So we want to prove these three lines are concurrent. Notice that the concurrent line, we want to prove lines are concurrent. We have a very simple method, which we discuss this at the beginning of this series of the videos, right? The Sievers theorem. And here we want to use the angle form of the Sievers theorem. Look at here that if I do this, we know this angle equals to this angle equals to this angle, right? Basically means this angle equals to this angle, and this angle equals to this angle. Also, this alpha equals to this one is alpha, right? So if we have this perpendicular line, we name it as DEF. Then we know that sine angle start from B, right? BICE to sine angle EICA times sine angle AIB F, right, to sine angle FIBC times sine angle CIA D to sine angle DIA B. If this equals to 1, then we just prove that using the converse theorem of Sievers theorem in angle form, right? We can directly prove that these three lines are concurrent. So look at here, the angle BICE is actually equal to the angle DIAB, right? Because this angle equals to this angle, so these two cancels. And the angle CIAD, this one actually equals to this one, which is FIBC, right? So this one and this one, they're equal, right? And for the angle AIBF, this one, because this is alpha, so this one equals to this one, equals to AICE, right? Or EICA, that's the same, right? They all cancel. So make it equals to 1. So we can use the converse theorem of the Sievers theorem in the angle form. We can just directly say that DIA, EIC, FIB are concurrent. Right. Okay. This problem is not a very difficult one. We just need to check on the relation of these angles. Basically, we need to understand how we find the center of side tangent circles, right? And then it's easy to prove these two questions. Okay. I hope you like this video. See you in next one. Thank you.